Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 1 class. It is 12.3, multiplying and dividing rational expressions. First, let's do a review of 12.2. 12.2, we talked about what you need to do is to factor, and then you can simplify the fraction. So in the numerator, I can take out a GCF of 2, which gets me x plus 3. Over, I need to factor tree 6, 1 times 6, 2 times 3. The middle term is positive, so the larger number is positive. The last term is positive, so the smaller number will also be positive. What multiply or adds to 5, that would be x plus 2, x plus 3. At this point, I can go ahead and cancel the x plus 3's, so I'm left with 2 over x plus 2. On problem 2, I have the issue of my denominator being backwards, so 4 or x minus 6 over, I'm going to rearrange, and then I'm going to take out a negative 1 as my GCF. What that allows me to do then is to cancel the x minus 6's. 1 over negative 1 will equal negative 1. That is the review. If you have any questions on 12.2, please make sure you come and see me. Examples of multiplying. What we're going to do here is we're going to multiply our different rational expressions. So what we're looking for is anything that I can cancel out. I can go ahead and try to cancel right away. Originally what you want to do is look to factor. You want to take out GCFs, you want to take the difference of two squares, you want to do whatever you can to simplify all four pieces. So I'm going to look at each piece individually. The top left piece is a 3. There's nothing I can do with a 3, so I'm going to go ahead and leave it alone. The bottom left is an x. Again, nothing I can do there. Top right is a 4, and bottom right is an x squared. None of those can be simplified, so what we do is we just leave them alone, and I'm going to go ahead and multiply. So 3 times 4 is 12. Over x times x squared is x to the third, and I will actually be done with that problem. Okay. On B, what I'm going to do is I do want to multiply here, but I'm not actually going to distribute. So this is going to turn into x times x minus 3 over x plus 4 times x minus 2. And I'm going to go ahead and leave that way. Okay. There's nothing I can simplify, and I'm going to go ahead and leave it the way it looks. On to C. Again, there's nothing I can do with C as far as simplifying. So 6 times negative 2 is negative 12. X squared times x to the third is x to the fifth. All right. Now I have to use factoring. What I want to do here is I'm going to factor any piece I can. So I'm going to look at the 2x plus 1, the top left corner first. Is there anything I can take out of that? Can I take out a 2? Can I take out a 1? Taking out a 1 doesn't really do anything for me. So there's not a whole heck of a lot I can do there. So I'm going to leave that as 2x plus 1 over. The denominator is a 3. There's nothing I can do with a 3, so I'm going to leave that alone. The top right is a 6x. Again, nothing I can do with that. 4x squared minus 1, though, I can do something. 4x squared and 1 are both perfect squares. So what I can do is take the difference of two squares. The square root of 4x squared is 2x, so that goes at the beginning. The square root of 1 is 1, so that goes at the end. Positive, negative. Okay? At this point, what I'm going to look to do is go ahead and cancel anything I can. It does not matter if they're in the same fraction. It only matters if they're in the numerator and the denominator. So this 2x plus 1 that's in the top left corner can cancel with the 2x plus 1 that's in the bottom right corner. The 3 can cancel the 6, making the 6 into a 2. At that point, there is nothing else I can do, so I'm going to go ahead and write what's left over. Well, I have the 2x left in the numerator over the 2x minus 1 left in the denominator, and I am done. Okay, so it doesn't matter if they're in the same fraction. I can simplify them even if they're in opposite fractions. So again, on E, what I'm looking to do is I'm looking to simplify as far as I can first. So x minus 2, can I simplify it? No, so I'm going to leave it alone. 8x, same thing. So I've done the entire left fraction to start with already. There's nothing I could do to simplify it. Now I'm going to look at the negative 8x minus 16. I do know there's a problem already because my x is negative, so I know I'm going to at least take out the GCF of negative 1. But then I look at 8 and 16. They're both divisible by 8, so I know I can take out a GCF of negative 8. Negative 8x divided by 8 is x. Negative 16 divided by negative 8 is positive 2. Okay, so that is as simplified as I can take it. Now I have x squared minus 4. Well, x squared minus 4 is the difference of two squares. So again, I can make two sets of parentheses. The square root of x squared is x. The square root of 4 is 2. 1 is positive. 1 is negative. At this point, I'm going to look to simplify what I can. So the x plus 2 and the x plus 2 are in the same fraction. One's in the numerator, one's in the denominator. I have x minus 2 in the top left corner, x minus 2 in the bottom right corner. And I also have negative 8 over 8. So the 8's will actually cancel, leaving me with negative 1 in the numerator. So I'll have negative 1 in the numerator over just an x. Okay? On to f. Can I do anything with 3x plus 1? No, I can't. So I'm going to leave that over. Can I do anything with 4? No. What about 8x? No, there's no factoring I can do with any of those. However, 9x squared minus 1 I can factor into 3x plus 1, 3x minus 1, because that is the difference of two squares. At this point, I can go ahead and simplify the 3x plus 1 from both sides. The 4 and the 8 can simplify, making the 8 a 2. So I'm left with 2x in the numerator and 3x minus 1 in the denominator. Okay? Which I know that part of this gets cut off, so if you can't see the bottom right corner of where I've factored, it is 3x plus 1 times 3x minus 1. That's where my 3x minus 1 came from. All right, on to G. On G, the first thing I want to do is I want to make sure I have two fractions. So I'm going to take this second expression, x squared plus 5x plus 6, and put it over 1. Now I'm going to go ahead and simplify what I can. 3x plus 2 cannot be simplified. There is no greatest common factor between 3 and 2. 2x plus 4 can be. I can take out a 2, leaving me with x plus 2. Times. Now, x squared plus 5x plus 6, I'm going to have to use generic factoring. So 1 times 6, 2 times 3. The middle term's positive, so they're both going to be positive. Then you multiply to a positive, so the smaller will also be positive. What multiplies to 5? That would be x plus 2, x plus 3. All that's still over 1. At this point, I'm done factoring. There's nothing more I can factor, so I'm going to go ahead and cancel what I can. Well, that would be the x plus 2's. So I'm left with 3x plus 2 times x plus 3 over 2. And that's the farthest I'm going to take it. What I'm not going to do, I'm never going to go back and distribute, because what that does is expands it instead of breaking it into pieces. That brings it back into one larger piece, and that's not what we're looking to do right now. We're looking to simplify. So that is the end of our lesson. The most important piece to remember here is the first step every single time is to look to factor. I'm going to factor all four pieces. Treat the top left as its own problem, the bottom left as its own problem, the top right as its own problem, and the bottom right as its own problem. Once you have them as simplified, as factored as possible, then you can go ahead and start canceling things out. Once you have them canceled out, remember, we're not going to ever multiply them back in together. We're going to leave what is left as a single fraction. If you have any questions over this lesson, please let me know. Otherwise, thank you very much for watching the video, and have a great day.